Hey everybody, today we're going to talk about the contrast between correlation and a new kind of statistical test we haven't talked about, which is a mean comparison. We'll get more into this as we get going here. Once again, a correlation looks at how much two variables are related to each other. It essentially answers three questions. Number one, are these two things related? Number two, how much are they related? And number three, in what direction are they related? For example, positively or negatively. Now that's very useful, very interesting, and sometimes that's the appropriate question to ask. It really depends on what you're doing. So let's give an example, however, about sometimes when that is the correct question, and then I'll show you how sometimes that's the wrong question to ask. So let's say that you've got a professor who has some data on the midterm evaluation and then the final course exam in their course. Let's say it looks something like this. These are just made up, of course, and let's imagine that we took the percentages there as the scores. So we could correlate these, right? There's nothing wrong with that because what we have here is paired observations. It's the same student who took the test, the two different tests. And so I know that this score goes with this score because of which student took it. And they're both continuous variables, so it's very easy to run a Pearson correlation, just like the one we talked about in our last few lectures. So let's do that. Let's say that we go ahead and correlate this information, and these actually are correlated, by the way, at a 0.48 correlation coefficient. So the correlation is 0.48. So that's useful, right? That's potentially very useful. I now know that they are related. I know that it's a moderate positive relationship. So if you did relatively well on the midterm, you can expect to also do relatively well on the final. They're positively correlated. Now it's moderate, meaning that it didn't work for everybody. Not everybody who did well on the midterm did well on the final, or vice versa, right? So that's useful. That's some potentially useful information, but perhaps that's not the question I want to ask as a professor. So maybe the professor isn't actually interested in whether they're correlated. In other words, they're not all that interested in whether the midterm grade is related to the final grade. In fact, in some ways, that's kind of a silly question because it seems like it should be for sure, right? You shouldn't need to have some evidence that they are related necessarily, but that's fine. So maybe the professor instead is asking which is the more difficult test. And maybe even beyond that, maybe the professor wants to know how much more difficult is one test from the other. That's fundamentally different from a correlation. In fact, if you tell me they're correlated at 0.48, that actually doesn't answer this question at all. It doesn't tell me anything about which test was more difficult. It doesn't tell me how far apart the scores were on average. For example, it doesn't tell me anything like that. So I would need a different test to be able to figure out which of these tests is different. In fact, it should be rather intuitive if I were to say, how could you figure out which test is more difficult? You might say, well, let's calculate the average scores, right? And as you can see here, this looks like the final had a higher score than the midterm. And so that may be some evidence that the midterm was more difficult. It also could mean some other things, maybe that people worked harder to study for their final, for example. It could mean some other things. But the point is, what we would probably want to compare is the average score of the midterm and the average score of the final. Now, this is just a very basic explanation of how mean comparisons work. So mean comparisons answer different questions than the correlation does. A mean comparison is fundamentally different from the correlation in that way, in that the mean comparison doesn't care about the covariance between two variables. It doesn't want to see how one variable seems to change with the other variable, for example. It's different than that. In fact, a mean comparison essentially contrasts two levels of a variable with each other based on some other variable. I'll give you some examples of that in just a minute to hopefully pin that down just a little bit more. But there are lots of different kinds of mean comparison tests. In this series, we're going to talk about really just a couple of them, and we're going to go start with very simple ones, and then I'll talk about a little bit more advanced ones, and we'll give some examples of some of these more advanced ones. But it's okay, it's a major portion of statistics is these mean comparisons, so it's very important that we get familiar with these. So let me give you a few examples of the differences between correlation and mean comparison tests. So again, a correlation is interested in how much and if two variables are related to each other. For example, if I were to ask, is sleep associated with mood? That sounds like a really good test for a correlation, a really good setup for a correlation. I might also ask, does music volume have any relation to your ability to concentrate, for example? I'm wanting to see how much these two things change with each other. That sounds like a correlation. That would be perfectly appropriate for that, depending, of course, on the design of the variables in the study. Now, a mean comparison is asking different questions, right? It wants to know whether and how much two things differ from each other, okay? Specifically, how two groups that we've treated differently, for example, differ from one another on some measure. So for example, I might ask, is therapy A more effective than therapy B at reducing anxiety? A correlation can't answer that question because a correlation would simply say, how much is therapy A associated with anxiety? And this doesn't exactly work anyway because that would be a binary variable, is which therapy works. There's really two levels, therapy A or therapy B, and then anxiety levels, we would imagine we're measuring that on some continuous measure. Okay, so because it's asking which one is different, we're contrasting two levels of the therapy variable across another measure, which is the measure of anxiety. That's a mean comparison. Another example might be something like this. Which classroom had more disruptions, right? I'm not interested in the correlation of disruptions with the classroom. That's a little bit different. That would be a little bit weird of a question. What I'm asking for is, did they meaningfully differ from each other? Classroom A or classroom 1 or classroom 2? And in this case, I'm contrasting the two levels of one variable across the other variable, which is disruptions. Another example, which of my cars gets better gas mileage? That's perfectly reasonable mean comparison. In other words, the one variable is which car, and it has only two options. It's my van or my truck, right? The other variable is gas mileage. So if I'm contrasting the one variable on its two levels across this measure that I have on the other variable, which is the other variable, the gas mileage, that's a mean comparison. And of course, there are lots of other things. I've done lots of t-tests in my own career, in my own research, and that kind of a thing, and it's a very common test. So we'll see this in a few examples. We'll start to gently introduce this over the next few lectures, and we'll get to calculating one in a little while. I'll see you then.